I'm excited to introduce the next presenter on today's VDI Ecocast. From Pivot3, Mr. Mike Componen. He's the Senior Director of Solutions Marketing. Are you there, Mike?
I am indeed here. Can you hear me okay?
I can. Thanks for being on. Take it away.
No, thank you for having me today, and thanks to everyone out there for joining the Ecocast today. I appreciate you taking the time out of your busy day to take and join us. And so as he mentioned, my name is Mike Componen, and I manage what's referred to as our Product and Solutions Marketing Group here at Pivot3. And just a little bit about me, I've been in the storage, the converged, the hyper-converged industry now for, going on 25 years to kind of date myself. So I guess I've kind of been, both witness and participant, in the evolution of growth of VDI over the years, and how those different types of infrastructures, have been able to support and grow in their capabilities to support VDI. So it's fun to be able to be on this webcast today, and talk to you about, what we do here at Pivot3. So what I'm going to try to accomplish in my time here is give you an overview of some of the advances in hyperconverged infrastructure, and how they benefit virtual desktop deployments, and then close, with a few examples of some deployments that we've done with some of our customers that kind of highlight what customers have been able to achieve, with Pivot3 and really their entire VDI solution deployment. But a good place to start is in the survey there, was actually a good lead into this, and I didn't even know that survey question was there. And I saw a slide from the previous presenter, that talked a bit about VDI challenges, because I think it's a good place to start, just to review these again, because this reflects what we're hearing from customers and what we see industry analysts talking about, in terms of the things that all of you struggle with, either as you try to scale out your VDI environments or as you look to deploying VDI for the first time. And I saw that 38.9% of the people answered cost and complexity as the key challenge. I've seen analysts speak to upwards of 50% of the cost of the VDI infrastructures being related to storage. And that's not just that hard fixed cost of acquiring and maintaining that storage infrastructure, but it's the whole environment. It's the deployment and the maintenance and management of the servers, the storage, the networking, the virtualization layer, et cetera. And you want to minimize that, obviously, as much as possible and reduce the amount of time you spend diddling around with that infrastructure, because you want to be more focused on serving the needs of the end users and delivering them what they need to do what they need to do for the business. And then I saw that performance was 36%. I guess it's kind of nice that these are lined up that way. And I know there's a lot of early on, there was a lot of talk about storage being able to deliver the the level of I/O as well as the consistent, predictable I/O that virtual desktops needed, particularly when you have those mass events like virus scans and boot storms and all those sort of things. But increasingly, with all flash-based systems, coming on the market and coming down in cost, I/O is less of a challenge, at least from the standpoint of delivering the raw I/O that you need, and more the focus now has gotten to be on latency, because latency is obviously really critical if you're going to equal or exceed the type of user experience that you want that virtual desktop user to have. And if anything's going to cause a VDI project and the acceptance of it by the organization, it's going to be delivering that poor user response time. People are just going to want to rush back to their desktops. And then the last one is around scalability. I know with the bulk of the customers that we work with, everyone's sort of starting with a pilot deployment, and scaling from there. And they've either got a plan mapped out at the start, they're going to do, say, a pilot of a 50 users or 100 users, and then they're going to scale up by departments, and they've got a known fixed number of users they're going to add, et cetera. But then you've also got the unpredictable things that happen where your company does an acquisition, or there's a group that wasn't supported in the company before that's now going to go mobile with their applications usage or something like that, and all of a sudden you've got this unpredictable scaling requirement, and so you want to be able to kind of know in advance that you can scale in predictable known quantities from both a user count and a cost standpoint, so that you don't have to go back to your management with surprises from a budgetary approval standpoint. So, and I know these things are kind of consistent with what the previous speaker spoke about and what's talked about in general, but I always think that's kind of a good starting point to kind of level set there. Now, I know many of you on the phone may be familiar with hyperconverged infrastructure, but for those of you who aren't, hyperconverged infrastructure takes and collapses the traditional external storage, standalone servers, virtualization software layer, and then storage network, down into a simple to deploy appliance, where you cluster the appliances together, into a system, based upon the application performance, a number of virtualized apps you want to deploy, as well as the amount of storage and the performance of storage that you need. So on each of these nodes in the hyperconverged infrastructure, you're both running virtualized applications, as well as you have a shared virtualized pool of storage that's made up of all the storage in the nodes in that cluster. And when you see research from industry analysts, whether it's Gartner, IDC, or there's another firm called Technology Business Research that does a twice annual survey of IT personnel, you see the reason that customers are going to hyperconverged infrastructures being a lot around speed to deploy, it being lower to take and operate and administer, and then just giving IT organizations more agility, since there's more of a known, predictable way to take and scale out a hyperconverged infrastructure. And in fact, the latest survey done by that firm, the Technology Business Research, TBR they're known as, the customers that they surveyed said that 55% of the customers who currently owned SAN systems plan to replace them with hyperconverged infrastructures, and then 31% of the people who are currently using NAS systems plan to take and replace them with hyperconverged infrastructure. And the reasoning was all around this, just simpler to deploy, manage, faster to deploy and manage. So there is indeed, significant growth, going on in the adoption of hyperconverged infrastructures, based upon those sorts of capabilities. So that kind of leads us to us, Pivot3. We're one of the leaders, acknowledged as one of the leaders, in the hyperconverged industry. We've been at this now, for around 12 years. We actually started out deploying software-defined storage, and then found that we could add the support of virtualized applications to our software-defined storage, and actually started doing hyperconverged before hyperconverged became a term in the industry. And so we're this past year, we were recognized by Forrester as being one of the top 3 hyperconverged vendors. We're recognized as a visionary. Gartner Magic Quadrant for integrated systems that covers all of the converged, hyperconverged type solutions. And we have thousands of customers in 53 countries around the world, deploying anywhere from one node all the way up to hundreds of nodes in a single deployment. And I'm not going to take and go into the 3x and 1 now, other than to kind of say that we're recognized by the industry analyst as being a leader in the performance, scale, and efficiency. I'm going to go into a bit of the architectural reasons why that is, and then specifically how that applies to being a good infrastructure for virtual desktops. Okay. So let's kind of talk about how we then apply our advantages then to VDI. First, as you saw in the previous slide, that due to the sort of performance that we can deliver, we've benchmarked ourselves as being able to support up to 3 times the number of users per node than other hyperconverged systems. And so the end result of that to you is you can buy less infrastructure to take and support the same number of virtual desktops, and it kind of gets back to addressing that cost issue that 39% of you say is your top challenge with virtual desktop infrastructure. Second is performance, and I'll show you how we're delivering on that with a very unique multi-tier architecture that utilizes NVMe, PCIe flash, all managed by an advanced quality of service engine to deliver ultra-low latency and high I/O, as well as making sure that that performance goes to the priority users that are most important to your business. So that kind of gets to that user experience requirement for having an effective VDI project. And then the last is a modular distributed architecture that does give you that simple predictable scalability. I refer to the fact that people start small, grow from there. Want to be able to do that in known increments of both cost, as well as number of users they're going to support. So we do indeed spend a lot of time, doing validation work with some of the standard tools in the industry to validate the number of users that our nodes and then our systems as they scale out will support. So it does indeed deliver you that, and I'll talk a little bit about how that is. Across the bottom, I show some of the what we refer to as technology alliance partners that we've worked with over the years to deliver VDI solutions for our common customers. And this is just a representative sample. I see the slide actually has to be updated since Unidesk is part of Citrix and AppSense is part of Avante. And I know Liquidware Labs is now Liquidware, and they're up after me here, so I hope they're not offended by that. But depending upon what type of industry you're in there in the audience, we're partnered up with someone where we have validated our solution, deployed our solution at customers with them. If you're in the financial services space and you have high performance graphics intensive sort of needs for traders and such, Amulet Hotkey is someone that we work with in that regard. There's another company that's not listed here that I'll show on a case study, HealthCast. So if you're in the healthcare space and you're trying to do things like single sign-on, follow me anywhere type of deployments for nurses and physicians, excellent solution there. Of course, NVIDIA for high-end graphics use. So you kind of get the point that we know that different industries have different needs when it comes to the type of solution we're going to deploy. So we reach out, establish deep relationships, both marketing support and technical with these companies, to ensure that we can deliver you a well-integrated, validated solution. Enough of that. So let's kind of get into, what the secret sauce is about Pivot3, that helps us be an effective infrastructure for VDI. And in fact, I'm going to take and build this out here because I know listening to lots of webcasts, I know the build outs can get a bit annoying at times. So let's start from the left and move right there. So in order to take and deliver you the performance that you need and the user experience that you need, we have what we refer to as a distributed scale-out architecture. As I mentioned earlier, hyperconverged infrastructures are based upon taking and deploying appliances or nodes in a clustered fashion, with each of those nodes being able to run virtualized applications, as well as be aggregated together to form a virtualized storage pool. And so what our hyperconverged software platform does is it has the ability to aggregate all of the resources from all of the nodes and present them to VMs regardless of what node they're residing on. So every VM on every node gets the full benefit of all of the disks in that aggregate pool of disks, from all of the individual nodes. And the same with cache. We create a global pool of cache as well that all the VMs take and benefit from. So that allows us to deliver, really high I/O, from the aggregate pool of disks, as also along with really great response time, because of the amount of cache that we can pool together from all the cache within the individual nodes. And it also takes and lends to then us being able to scale in a predictable, linear fashion, because every time you add a node to the cluster, the resources from that node are being brought into the pool, and we have a good performance profile of exactly what that's going to take and add to the node from a performance standpoint. And so you get a nice linear performance and capacity pool as you add nodes to the cluster. In the middle there is something that is called erasure coding, and we actually have a patented form of erasure coding that we've been using since day one of Pivot3, so we're actually on our 7th generation. And think of erasure coding, as a successor to RAID. It's a more efficient way, a more intelligent way to take and distribute, blocks across all of the disks in all of the nodes of the cluster to ensure that you've got protection against, either multiple drive failures or a complete node failure. And it's actually a more storage efficient way to take and do data protection. Because what you'll find other hyperconverged infrastructures players doing, in order to protect from an entire node failure, they'll take and copy data across nodes in the cluster, so that if an entire node is lost, then you've got that data, that complete data set available on another node in the cluster. Well, that's very inefficient from a storage utilization standpoint, and that's what you see represented on the chart here. So if you're creating kind of a one copy across the node, you've got 50% storage utilization. You've got creating 2 copies for a higher degree of resiliency. You've got 33% storage utilization. Whereas with erasure coding, you can, depending upon the number of nodes, type of erasure coding level you're using, you can achieve up to 94% storage utilization. So if you've got 100 terabytes of storage, you've got 94 terabytes of that usable capacity. And on the far right, and I'm going to take and go into this in just a little bit more detail, is we have recently added an NVMe flash tier to our hyperconverged nodes that is managed by an advanced quality of service engine. And the NVMe flash, delivers us the ability to take and deliver, much lower latency than we had previously, and do other hyperconverged infrastructure players. And if you're familiar with, NVMe PCIe flash, you know that it's 2 to 6 times faster than SAS or SATA SSDs that sit behind a traditional RAID controller. With that traditional RAID controller, actually inserting a bottleneck so that you don't really fully realize the performance potential that exists in that flash. And so us bringing in that NVMe PCIe flash tier into the hyperconverged nodes, allows us to deliver this, really neat combination of, ultra low latency as well as high capacity and high IOPS. So I'm going to dig into the quality of service here in just a bit. All right, and in fact, that just a bit is right now. And so, Pivot3, has actually been deploying, quality of service now, with our customers for over 4 years, and we refer to it, as advanced quality of service because our quality of service operates, on 4 different attributes: policies, priorities, placement, and protection. Think of it as the 4 P's of quality of service. And so we have predefined policies that specify, IOPS and throughput and latency targets. There's 5 of those policies. And then, so all a user has to do is take, and when you provision a volume near a data store or a VM, you just take and assign one of those 5 predefined policies to that entity. And now the system knows what applications are more important than others. A policy 1 VM is going to have a higher priority level when it comes to utilization of resources in the system than a policy 5 VM. So when there's points of contention, what you have put in that policy 1 is going to receive real-time prioritization, of the data path and of the data movement and of the operations within the hyperconverged system. And how it's doing that is it's making real-time decisions on where to place the data in the system in order to maintain that policy that was set. And I didn't refer to it on the previous slide, but the hyperconverged system utilizes what we refer to as a multi-tier architecture. So it has that NVMe PCIe flash storage media in it. It also has, and we use that as both a read-write cache and a persistent tier of storage, as well as RAM as cache, and then either SSDs if it's an all-flash node, or hard drives if it's a hybrid node. This quality of service engine is moving blocks in real time, between those storage media types in order to ensure that performance policy that the user set, is maintained. And then we also have provide users the ability to build their own data protection policies that specify snapshot retention, those sorts of things as well. So this provides, well, let me just go to the next slide here. I think this illustrates it a bit, well, one more actually. So the Pivot3 hyperconverged system, is an ESXi-based solution. So we provide you the ability to take and manage, the entire infrastructure, from the familiar, friendly vCenter console. So we have a plug-in that exposes, all of the attributes of the system, including sophisticated performance reporting and monitoring, so that you can manage, both your virtual applications and your virtualized infrastructure, along with your hyperconverged solution, all from that familiar vCenter console. Okay, now I'm going to take and dig into the policy-based management. So let's talk about how this would take and apply, to a user environment where you had, task workers, knowledge workers, and power users. You've probably heard those referred to on other VDI webcasts and are familiar with them. They all have different user profiles and different performance demands, on the infrastructure. So let's say you've got an environment, of these 3 different types of users. And here you've got a hyperconverged infrastructure that consists of 3 nodes. Okay, what you would do is you could take and place your power user and put them in performance policy 1. So that's classified as a mission critical service level. In the event of contention or noisy neighbor type activity, those are the VMs then that are going to get resource priority in real time over any of the other classes of VMs on the solution. Then you might take in place your knowledge workers in policy 2 or 3. That's classified as a business critical service level and has the next order of priority. And then take in place your task users who have less performance-intensive requirements, and due to the nature of their positions, may not need priority access to performance and response time, and such. You place them in either performance policy of 4 or 5 that's classified as non-critical. Let me just show you then the way this would play out in periods of noisy neighbor or contention. So if you've got a traditional infrastructure with those 3 types of users displayed there again, the task and the knowledge and the power users, let's say you've got something going on with those task users, say an update being pushed out that's being the patch is being retrieved and expanded and installed and reboots and all that type of stuff. And so there's a performance, blip from those task users. Well, in a traditional infrastructure, since the system can't distinguish between which type of VMs are more important, then both your knowledge workers and your power users' performance is going to be impacted. Now, contrast that with the deployment of quality of service. So I mentioned earlier, that you've told the system that the VMs, holding those power users are mission critical. They're more important than the other ones. So if you have that same blip in performance demands from the task users, it's going to take and automatically hold back the amount of performance that they get if the ability of those of the power users to sustain their IOPS throughputs and latency targets looks like it's going to be impacted. Now, if the system's got enough performance to serve all 3 of those to the performance levels they're placing on the system, then it will. And that's one of the differences, between the type of quality of service, that we implement at Pivot3 and other people who are talking about quality of service is they'll place kind of artificial maxes, or mins on volumes or VMs. And why would you want to do that? If the system's capable of servicing everybody, let it service everybody. Only if let's say those power users' performance is going to be impacted and it's going to fall below the target you set, only then would you take and throttle back, and limit the less critical users. So that's kind of why we refer to this as a more advanced or sophisticated quality of service capability. I talked about the density before, from the standpoint of this distributed architecture, the incorporation of NVMe PCIe flash. We have demonstrated that we can take and drive, industry-leading density, on a per node and a per system basis. The one on the left kind of indicates the improvements we made with the solution that we introduced recently that we refer to as Acuity. Previous generation product that we have we refer to as vStack. So we made significant performance advancements just over our own product. But then when we benchmark against other leading hyperconverged vendors out there, we see that we're able to take and support 80% more users per node, and that's comparing numbers that we generate with login VSI, the same tool as the other vendors take and utilize and publish against. Right, a couple quick deployment examples here. First is a large U.S. federal agency, and because it's a federal agency, I'm not allowed to take and mention their name. And this one is a good animation here because their requirement is around how do we take and deploy something, in the smallest footprint possible, and then also optimize around cost as well. And at Pivot3, we can take and deploy hyperconverged solutions either as Pivot3 branded appliances. So there you see those nice orange boxes there, either on the 2U or 1U or blade system form factors, or we can take and deploy our software. You can purchase our software and deploy it on servers separately. And so this one kind of shows an interesting combination of using a Dell FX2 blade system combined with our hybrid nodes to take and have this nice kind of combination of high compute density but lower cost capacity of storage. And so here, the customer started out at 1,000 desktops, with kind of this mix of higher power users, versus lower power users, and then they wanted to scale up to 1,500. So they added a FX2 blade chassis and one more node. Then as they wanted to scale up to 2,000 desktops, all they wound up adding was a couple of more of the hyperconverged nodes. So this example is intended to show you that there's a degree of flexibility here to take and kind of optimize things based upon the type of form factor that we can deploy on, either blade systems or 2U rack server nodes. And and recall too that each of those nodes is both supporting a VM as well as acting as a contributor to the overall storage pool that's created by the aggregate capacity of all of those nodes. And then the other example is one I can mention the name of, Southern New Hampshire Health System. It's a healthcare provider in New Hampshire who has 20 campuses, services 10,000 different patients per year. Their requirement was a bit different. They really needed to have something in place that had the ultimate in resiliency and high availability, since they didn't want to have nurses and doctors access to critical patient information impacted if there was some type of outage. So they deployed two identical data centers, load balanced by F5 load balancers. They used HealthCast for single sign-on, and for doctors and nurses to be able to take and sign in on mobile carts and have sessions active as they moved between different patients. And here, the deployment was a bit more traditional from a Pivot3 standpoint, in that they had the 2U Pivot3 branded hyperconverged nodes. They were hybrid in this case, deployed at each data center. And the key thing for them was having this resilient, highly available environment. And so the fact that our erasure coding that can take and survive multiple drive failures, an entire node failure, yet maintain upwards of 85% plus performance in the event of a failure, really took and satisfied their need for that high availability. And from their standpoint, it was all about improved patient care, physician productivity. So the hyperconverged solution really delivered that for them. And then lastly, people ask a lot about how do I take and leverage the cloud for VDI. I'll just take and make you aware that Pivot3 is a validated hyperconverged infrastructure with VMware's Horizon Cloud solution. That's a solution where you take and do all of the management of your master images and clones and layers and all of that kind of up in the cloud layer. But when it comes to actually deploying the VMs, you take and just download those from the cloud and take and deploy them on your on-prem infrastructure. So you have local control and protection of the user data on your on-prem infrastructure. And VMware is exclusively recommending hyperconverged infrastructure to be used with the Horizon Cloud, and so it's important that they recognize us as a validated solution with their cloud product. And then I'll just also add, as I close here, because I didn't refer to this earlier, but just kind of took it for an assumption, that we are indeed a Horizon View, end user computing validated solution. We have multiple reference architectures in place around Horizon View. In fact, Pivot3 was the first company back in 2011 or 12 to be validated in the VMware Horizon always-on desktop program that was targeted for healthcare providers. And then the same goes for Citrix Ready. We are a validated solution as well with Citrix Zen Desktop. So hopefully I've given you some insight here into how we deliver really high density to help you with that cost challenge that you've got. We deliver the type of both I/O and low latency performance that you need to address that performance challenge you have. And then as you figure out how you're going to start and then scale out your infrastructure, we can also help you plan that in a very predictable sort of fashion from both a cost and a number of users you support standpoint. So with that, I will wrap up. Thank you, everyone. I appreciate you listening and attending today.
Great presentation, Mike. Thank you very much. So we've got some questions here from the audience for you. If you have a few minutes to chat about those. If you are out there in the audience, if you haven't asked a question, now's the time to do it. This is Q&A time. So, Mike, are you ready? Okay. Awesome. So, Mike, you talked about scalability, with hyperconvergence, and I know you said you have scaled to some pretty large customers, but I wanted to ask a little bit more technical information, about how does Pivot3 exactly address scaling?
Well, scaling is addressed through, adding, oops, I heard a scratch there on the line. We address scaling, by, adding nodes, to a cluster. As a node is added to the cluster, it's brought into the cluster, in a non-disruptive fashion, and all of the disks, be they SSDs or HDDs, are brought into the aggregate, the existing pool of storage and added as resources to that. So any VM on any node, now has the benefit, from the performance from those additional drives, as well as the cache that was brought in from that node. So that kind of us to scale in this predictable linear fashion, since we know exactly how much additional performance was brought in with each node, and it is indeed done non-disruptively as well. Once the node is brought into the cluster, everything is remapped across that entire cluster, as a background process with no disruption of VM access to data.
Okay, awesome. And then I think we just have probably one more question, or time for one more question, and that is, how does Pivot3 work with VDI in the cloud?
Yeah, good question, and that was the one that I touched on with the Horizon Cloud integration. So there we can act as on-prem infrastructure for Horizon Cloud, where you're doing your management of the desktop environment and the provisioning, with Horizon, accessing that software kind of on a software as a service basis. But then when it comes to deploying it, you can take and download, if you will, virtual appliances from the cloud that are deployed on the Pivot3 infrastructure that's sitting on site. So then you then control the amount of performance that those virtual appliances and users are receiving, and you have then local control of the data that's associated with them.
Okay. Okay, excellent. Well, I think that's all the time we have for the live Q&A. There might be some more questions for you there in the queue, Mike. Thanks so much for being on today.
You bet. Appreciate it, and thanks everyone for the time today.